Okay, one last thing for today. Let's talk about EPO, erythropoietin. This is a cyclist's best friend because EPO is the hormone responsible for making your kidneys, or the signal in your kidneys to have them start producing more red blood cells. So if you have low oxygen in your blood and your kidneys sense it, they're going to secrete EPO. EPO is going to be the signal for more manufacture of red blood cells to increase your oxygen delivery to working tissues. All right, so the first thing we're going to sense is blood's going to come in to the kidneys, and it's going to have a decreased O2. It's going to be sensed in the kidneys that there's not enough oxygen. The kidneys are then going to respond to this, and they're going to secrete EPO at this point. So then once the kidneys secrete EPO, it increases our plasma EPO concentration at that point. So now EPO is floating around our bloodstream. It's going to finally land on a receptor at our bone marrow, which is going to institute increased production of RBCs. Because we need to get more oxygen to the working tissues, and if we don't have enough, we need to find a way or have a signal so that our bone marrow knows to start producing red blood cells. So once they start producing more red blood cells mean an increase in hemoglobin, because more red blood cells means more hemoglobin, so an increase in hemoglobin concentration. That increases the carrying capacity of blood for O2. So more O2 is going to be carried via hemoglobin, and then that's going to increase O2 delivery to working tissues. So EPO is a neat one though, because it is one of the most abused substances in endurance sports. So you can easily see why that would be important, because in endurance sports, O2 delivery is one of the most important things in endurance sports. If you can get more oxygen to the working tissue, that oxygen is going to be the final electron acceptor in oxidative phosphorylation. Therefore, more ATP is going to be produced the more oxygen you have available. So anytime you're looking at it from a performance standpoint, this is not necessarily low. This is probably pretty normal. And as you increase your EPO concentration with exogenous or unnatural, you're going to produce more EPO, increase your plasma EPO, the bone marrow is going to produce more red blood cells, increase the hemoglobin concentration, and therefore get more O2 into the bloodstream that can be delivered to the working tissue. The problem is, remember our hematocrit? Hematocrit is normally about 45% in a normal person, normal male. So if we're looking at a cyclist who had a normal hematocrit as it was, and decided to dope, what they would do is they would take EPO and microdose it. It is a water-soluble hormone, so it's going to be high concentrations are going to be excreted via urine very quickly. So a microdose of this will increase your red blood cells, which would therefore increase your hematocrit or your O2 delivery to working tissues to a point. What ends up happening is, if you take too much EPO, your hematocrit now looks like this. One of the famous cyclists had a hematocrit of almost 67%. Remember we talked earlier about, in another video we spoke quickly about viscosity. So if we have a hematocrit of 67% versus 45%, and we had a person with 5 liters of blood times 0.45, that gave us 2.5 liters of RBCs. The cyclist, though, at 5.0 liters of blood times 0.67 yields a much different category of now has 3.4 liters of red blood cells. And if we look at that from a aspect of percent change, we're looking at a 25% increase in RBCs. So therefore you can see the effect of doping. The other problem is when you increase the viscosity of blood to 67%, it gets the consistency of motor oil. So you have more proteins, more red blood cells, more cells into the blood, therefore exerting more osmotic pressure on the circulatory system, the arteries and veins. So as well as the viscosity being very high like motor oil makes it very difficult for the heart to pump it. And this leads to a troublesome situation where essentially the EPO has caused so many red blood cells that your blood has become thick, your heart can't pump it, and you end up in a state where death is most likely the option on it.